Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we like to call Space Nuts, 2 in a pack. My name's Andrew Dunkley, your host, and joining us, as always, is astronomer Fred Watson. Hello, Fred.
Hi, Andrew. So I thought there were more nuts in this pack than just 2. A few bolts as well.
We've got several packets going out over the internet. Boom, boom.
Yeah, pretty good.
But, yeah. Well, anyone can jump in on this. This is fine. Now, we've got a lot to talk about today and some interesting stuff, and a few people have probably picked up on this story about the Parker Solar Probe heading off to take a look at the sun and try and figure out a few things like why it's hotter on the outside than the inside and things like that. Yep. The Perseid meteor shower is happening at the moment, and that gives us a chance to talk about dirt. And and a question from Andre in Amsterdam. Hello, Andre. I've just been to Amsterdam. Why didn't you show me who you were? You could have waved. I would have said hello. Anyway, Andre has sent us a question about whether or not a black hole is really a hole. And that's a great question, really, when you get down to the nuts and bolts of it. So we'll tackle that one. But we're off to the sun, Fred. This is a thing that fascinates and amazes people constantly, especially when there's an eclipse that gives you a better view of the corona and things like that. I remember watching a BBC documentary that someone gave me on DVD in the days of DVD not so long ago, and it was called The Planets. And there was one episode that my eyes sort of opened and my brain went, what? When they announced how somebody discovered that our sun was a star. And I'd never thought of it in those terms. I mean, I knew it was, but there was a time where people didn't equate the sun to being the same as all those other things out there. And then it sort of became a huge revelation. And we've been so fascinated with it, all through time, really, haven't we?
Indeed, we have. And you're absolutely right. I think it was relatively late. I think it was in the early 19th century that people finally figured out that those little things you see in the sky are just like the sun, but we see them a lot further away.
Yeah.
But the sun, the most well-studied star of all, but still has mysteries. And you've alluded to one already. Why is the outer atmosphere, the corona, so much hotter than the surface is? It should be the other way around. The surface of the sun is roughly 5,500.
I'm going with the heat rises theory.
I'll just tell them to cancel the probe. I've
saved them billions.
Bit late now. Whereas the solar surface is about 5,500 degrees, whereas the outer atmosphere has temperatures measured in millions, probably tens of millions, in fact. Although it's much more rarefied. It's in a way what you're talking about when you talk about a rarefied atmosphere like that is a few particles, but they're moving very, very quickly because it's the movement of particles that tells us how what the temperature of a medium is. Anyway, that is a mystery. And so on Sunday, just gone, the Parker Solar Probe was launched. It was launched on a Delta IV Heavy rocket, which might sound like overkill for something that's only about the size of a small car. Why do you need a Delta IV Heavy, which is one of the most powerful launch vehicles in the armory of the United Launch Alliance, which is the company that launched it? Why do you need such a big rocket? And the answer is perhaps a little bit unexpected. Remember, the sun is only only, I'm putting in inverted commas here, but it's 150 million kilometers away. This is basically the same rocket that sends things out to the far distant reaches of the solar system. And so why do you need something that powerful to get to such a short distance?
Because they had a spare one.
They probably did have a spare one. Yeah, that might be it. The answer is that it's quite difficult to get to the sun. And even though it's relatively nearby in cosmic terms, it is, it's not exactly unreachable, but it's quite a major challenge in terms of the amount of energy that you've got to expend to get there. And the reason for that, even though you're falling into the gravitational well of the solar system, you're falling inwards, what you've got to do is lose the energy of the Earth's rotation, because the Earth's carrying around you around the sun at 30 kilometers per second, and you've got to get rid of that in order to fall in towards the sun. And so that's why you need such a big rocket. And in fact, there's more than that. There will be a gravitational slingshot with Venus later in the spacecraft's trajectory. I can't remember whether I can tell you when that will be. Yes, the Venus flyby. In fact, there are actually two, but the first one is the end of September, the end of next month. It will fly by Venus. And normally when you think of these, gravitational slingshots, it's adding velocity to a spacecraft. But in this case, it's subtracting velocity, because what you do is you give a little bit of your momentum in the spacecraft to the planet Venus, and that slows you down. And once again, that's the object of the exercise, to bring the spacecraft into an orbit that will still be elongated. It will be an orbit that will actually stretch out beyond the orbit of Venus, but it will take the spacecraft to within literally a few million kilometers of the solar surface. I think it comes down, when you do the sums, I think it is something like 4% of the distance between ourselves and the sun.
And what's the condition of that part of space like?
It's very hot. It's very hot.
I was going to say, how is it going to survive?
So it's got a heat shield, a carbon based heat shield that sticks out basically in front of the spacecraft, and prevents the radiation from the sun itself from melting all the metal components, which we did. And in fact, behind the heat shield, the temperatures, I think it's almost like room temperature. It's a hot room temperature rather than being something measured in millions of degrees.
It's just so hard to get your head around. But we see that on Mercury. On one side,
exactly, we do.
It's extraordinarily hot and would fry an egg in a thousandth of a millionth of a second, and on the other side, you freeze.
Yeah, that's right. It's the same sort of technology, or the same sort of physics that keeps Mercury cool on the dark side is being used with the heat shield that has a hot side and a cool side. So you might wonder why it's called the Parker Solar Probe. It is named after.
Let me guess. It's named after Parker from the Thunderbirds.
Okay, well that's pretty good, because that's not what I thought you were going to say. I thought you were going to say it was funded by the pen company.
Well, I used to do that. I used to get my Parker pen and I'd put it upright and I'd push it down and I'd let go and it would launch about an inch.
There you go. That's
a feasible argument.
And it probably had a heat shield as well. Yeah. When I was 14, my Parker pen was my prized possession. I'm not sure why, but yeah. You
give a kid one these days and they go, "Oh, that's lame."
Yeah. Anyway, it's not named after either Parker from the Thunderbirds or after Parker pens. It's named after Dr. Eugene Parker, who was the guy back in the 1960s who proposed the existence of the solar wind, this wind of particles that blows from the sun, and essentially is what controls some of the conditions here on Earth. He was building on work by other scientists. Actually, one of my great scientific heroes is a Norwegian called Christian Birkeland, and he, at the turn of the 20th century, was doing experiments to show that electrons, as we call them now, he called them cathode rays, come from the sun and cause the aurora, the northern and southern lights. Of course, being Norwegian, he was very familiar with them.
Yes.
But Eugene Parker basically tidied all that up, gave us the idea of the solar wind, and was present at the launch last week. He is now 91 years old.
Oh, wow.
Good on him. He looks terrific as well.
Yeah, I saw him. It's fantastic.
Yeah.
I also thought it could have been named after the Australian colloquialism, Parker just there. Close enough.
Well, it is going to be close, yeah. It's not, and in fact, in some ways, it is being parked there because it's in an orbit that is quite stable, or it will wind up in an orbit that's stable. I think it makes 24 orbits of the sun in what if I remember rightly, is a 7-year mission to understand the solar corona. But as I said, it's a very elongated orbit, so it's only in the hot bit for a short time. What will happen to the spacecraft in the end is that that orbit is stable, so it's not going to kind of wander off anywhere. But as it runs out of fuel, it will not have the vernier rockets, the little rocket motors that keep it pointed in the right direction. They will run out of fuel, so you can't keep the heat shield pointed towards the sun. And basically, it will just get hot and it will warm up and it probably just break up.
Where is all the science in this? Why didn't they just send it up with some solar panels? I mean, really, come on. Use some lateral thought, people.
That's right. But you would still have run out of fuel because even with solar panels. So what you're thinking of is plasma propulsion, where you
that's what I was thinking. Absolutely.
You've got a gas, and you accelerate it electrically to form a thrust, which is the only reason you'd need solar panels. The problem is it still runs out of fuel because the propellant gas runs out. So your idea of solar panels, Andrew, whilst original and thought-provoking, is crap. It's not going to work.
Okay. That's why I'm on this side of the microphone.
No, it's good thinking. Well thought out, but it doesn't carry through. There's just one little twist to this story that brings it kind of back to earth a little bit, because on Sunday, I got a couple of reports from people at different places in New South Wales. One was near Tamworth, which is in northwestern New South Wales.
I used to live there.
300 kilometres from you or something like that.
Mm-hmm.
Another from Crescent Head, which is on the coast, and both are the same thing, which was near the planet Venus, which is setting in the western sky at the moment, not long after sunset. They saw a peculiar 3-lobed cloud, a bright cloud in the sky. And they both the same thing. And I'm pretty sure that was fuel dumping from the final stage of the launching rocket, because it was just about an hour after the spacecraft had been launched that they saw that. I'm ready to stand corrected. I couldn't find a note of what the trajectory of the spacecraft was as it left the Earth, as to whether it actually did pass over Australia or whether the lower stages did. But it seems likely that was fuel coming from because you dump the fuel before they re-enter. Fuel. Very, very interesting stuff. In fact, one gentleman sent me some photographs of it. Thank you, Jim, for those.
And so we're going to be learning over the next 7 years as much as possible. Is it just the corona they're focused on, or are they going to be looking at other elements of the sun?
I'm sure that the whole. I mean, we should, depending on how long they can peep outside the heat shield, we should see some really interesting images of the solar photosphere. The photosphere is the surface that we see. It's not really a surface because the sun's a ball of gas, but that's what we actually see when we look at the sun. It's the energetic bit that glows brilliant white.
Yeah, they're going to need some pretty amazing technology on this thing to capture. Are they going to be taking photographs? Because at that distance, they'd overexpose.
We'll wait and see.
All right. Oh, and one final point. I think I read, and I think it was in respect to this this probe, that it's going to be the fastest object we've ever put up.
Yeah, that's right. Yes. So thanks for reminding me about that. It's as you probably know, if you've got something in an elongated orbit, and it was Kepler who told us all this back in the beginning of the 17th century, as an object goes around in an orbit, when it's closest to the sun, it's traveling at its fastest, and when it's away from the sun, it's traveling slower. That's the laws of, celestial mechanics, as we call it. And so you put the Parker Solar Probe in an orbit that will carry it past the sun at its nearest point, and at that point, it's traveling at about 190 kilometers per second.
Wow!
Which is, 10 times faster almost than anything else that's ever been launched. But it's really just the gravitational pull of the sun that's doing that. It will slow down as it gets further out. But really, extraordinary stuff.
Indeed. All right. Well, more to come from the Parker Solar Probe, I'm sure. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we move from the sun to dirt. At the moment, our planet is passing through the Perseid meteor shower. Do we pass through that, or does it pass us? I think we pass through it.
We pass like ships in the night.
Yes. But it sort of moving. It gives us a good opportunity to talk about these things and the dirt that surrounds us, and that's really what it is. We're surrounded by dirt and dust and all that sort of stuff. But it also makes some amazing sights for people to look at when these things hit our atmosphere, because there are a few famous showers every year. Leonids is another one, I think, isn't it?
Yep. The Geminids and the Orionids, they're all... So that kind of gives you a hint as to how these things are named. They're named after constellations. And the reason for that is that a meteor shower is defined as being a whole clutch of meteors that seem to come from the same region of the sky. And so you can identify it with a constellation. And that region of the sky is called the radiant, because it's where the meteors seem to radiate from. In the case of the Perseids, it's the constellation of Perseus, which is a northern hemisphere constellation, Andrew, and that's kind of why the Perseids are not that good seen from here in the south, although we can still see them, but you get better views in the northern hemisphere. So why do they seem to come from a single point? Well, actually what's happening is that you've got all these little particles of dust, exactly as you've said, which are entering the atmosphere, and they're all following parallel tracks. They're coming in parallel, but perspective from our vantage point on Earth, makes parallel things look as though they radiate from a single point. It's the old, railway lines disappearing into the distance trick. They're parallel, but they seem to converge on a distant point on the horizon.
Yes.
So it's the same with meteors. They seem to spray out from a single point. So what are we actually seeing here, and why do these showers come at different times throughout the year? And by the way, it's pretty easy these days to find out about the various meteor showers that you might see throughout the year. And it's worth a look because there are some pretty good ones. I'm only mentioning the Perseids because they're one of the most reliable showers, if I can put it that way, in that you get usually about one Perseid meteor a minute when the shower is at its height. It's probably past its height already this year. The pundits reckon that it was the 13th of August that we received the peak, but the shower tends to dwindle away slowly. It doesn't just stop. So it basically will probably be worth looking out until maybe the 20th of August, 24th of August or something like that. So that sort of gives you a clue as to what's going on here. What's happening is, as you said at the beginning, the Earth is passing through a cloud of dust particles as it moves in its orbit. But the question, I suppose, is where does the dust come from? And in fact, we know where it comes from. It comes from a comet, which is called Swift-Tuttle. All meteor showers are identified with comets. And comets are objects that are in, once again, like the Parker Solar Probe, in very elongated orbits. They either come in and disappear and they're never seen again, or they come in on orbits that might last for a couple of hundred years or something like that, but they're very, very elongated. And so the orbits of comets are very dusty places because comets, whilst they're made mostly of ice, they've got a lot of dust in them. And as they get near the sun, the ice vaporizes and releases the dust. So comet orbits are kind of pretty mucky. They're laden with dirt, and that means that as the Earth plows through them, we get these displays of meteors. So comet Swift-Tuttle has an orbit that's 133 years long. It was discovered, if I remember rightly, in the 1860s. By Mr. Swift and Mr. Tuttle, and hence its name. I think its first recorded appearance was actually in the year 36 AD. So it's one that we've, when you trace back, you can see that it's appeared several times. There'll be probably Chinese records or something like that. Yeah. But modern history dates it back to the 1860s. 133-year orbit, very dusty orbit, and it's also, the dust is spread over quite a wide area. So, if you imagine this dust trail, it's not a narrow dust trail, it's a pretty wide one that it's leaving behind. And that's why the meteors, why we see these meteors over a fairly long period, typically from middle of July to late in August.
So this particular comet is an Eastern Bloc vehicle, as against the cleaner Western type of vehicle that we know and love.
I'm not sure where you're going with that one, but I think you're thinking of the old Trabants. And
yeah, I saw one while we were in Berlin, and that's what popped into my head, the filthy old things.
We drive in them when we go to Berlin.
Do you? I couldn't.
Yeah, we do, yeah. You can get
I think you'd end up having to push it along like Fred Flintstone.
Honestly, there are times when it's like that. That is slightly off the topic there, Andrew.
Yeah, funny that.
But
I've never done that before.
No, never wandered off. Look, the Perseids, it's, as I said, it's kind of past its peak now. If you're in the northern hemisphere, it is still worth having a look. Comet Swift-Tuttle, I think, comes back in 2115 or something like that.
Well, we'll talk about it again then.
Well, we'll talk about it nearer the time, that's right.
It does prompt a question in my mind, strangely enough. Is it possible there are comets in longer orbits that we just have not seen yet that could be coming our way one day?
Yeah. And in fact... the comets come in two varieties, short period and long period. And long period comets are ones with, that basically we've only ever seen once. They come in, swing around the sun, and then head off again into the wide blue yonder. Where do they come from? They come from a kind of cloud of these cometary objects, which is, we call it the Oort cloud. It's like a spherical shell of stuff surrounding the sun, but it's a long, long way away. It's way beyond the planet Neptune and all the trans-Neptunian objects, the Kuiper Belt objects, way, way out beyond all of those. And so that's, we think, the kind of source of comets. What tends to happen, though, is sometimes these things come into the inner solar system and their orbit is modified because they pass close to the planet Jupiter, and that swings them into a shorter period. So things like Halley's Comet and indeed Comet Swift-Tuttle have almost certainly interacted with Jupiter at some time in their history. So yes, there are comets that we don't know about. There are things on their way into the inner solar system as we speak that we haven't discovered yet. But, we keep an eye out for them.
Well, we have to, don't we?
Yeah, we do.
Yeah.
We do.
Okay, so if you're in the Northern Hemisphere specifically, keep an eye out over the next week or two for the Perseid meteor shower. It might be worth having a look at. And many other showers still to come. This is Space Nuts, Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, as has become our great joy, a question from our vast audience of 4. And this one comes from Andre in Amsterdam. And before I ask the question, Andre, may I compliment you on your wonderful city? I just adored it. Judy and I loved it. Judy's actually half Dutch. Her mum was from the Netherlands. And so that's why we wanted to see it. Judy wanted to see her homeland, more or less. And and we think we found the town where her mother lived, but we weren't sure because we don't have any records. But, oh, damn it. There goes my phone. And that was my wife.
Just as you were talking about right on cue.
Yes, must have been some
sort of saying about my ancestors.
Psychic connection there. But yeah, wonderful city. Loved Amsterdam. Really enjoyed visiting it, Andre. So let's get to your question. I'm pretty sure Andre's messaged us before. I understand the black part of a black hole since there is no visible light being emitted. His question is, are black holes really holes? The hole I cannot grasp. In my mind, the black hole is actual matter, same as a planet, moon or star, but the mass is so dense that the resulting gravity is strong enough to hold light in. One could call it an inside-out star. Light is not emitted but retained. Or is a black hole pure energy? All matter that is being absorbed by the black hole is converted into pure energy, meaning MC2 term in the formula E equals MC squared is annihilated. No matter, no light, just energy. Is it really a hole? What does that mean? A hole is what? What determines the size of a hole? And where has all the matter eaten by the black hole gone? Oh, he's got you there. That's a brilliant question.
It is a great question. And he's hit the nail on the head, actually. Andre's comment, in my mind, the black hole is actual matter, is quite correct. It is. Although, as he says later on, because of the extreme form of this matter, it's turned into energy, E equals mc squared, by that wonderful equation. So we call a black hole basically a singularity, and a singularity is a single point in space with curious properties. And in this case, the property of the black hole is, and this is the formal definition of a black hole, okay? It is a point in space where the density is infinite.
Okay.
So density, we think of things in grams per cubic centimetre. The density of water is 1. Heavy things like lead have got higher densities, lighter things have got lower densities, and we all understand that. But in a black hole, it is a single point with infinite density. The density's gone up to infinity. And that gives it really curious properties in the gravitational world. It means that it sits at the bottom of what we call a gravitational well, where the change in gravity is very, very rapid. And that's actually why black holes have their peculiar properties. So the properties of a black hole, they were first investigated. I should check this, but I think Schwarzschild, who was an early physicist, a theoretical physicist, a mathematician, he looked at the properties of black holes within weeks of Einstein publishing his theory of general relativity. And it must have been within weeks, because he was dead by the middle of the following year. This was during the First World War. Schwarzschild actually died of a fever, I think, serving on the Eastern Front. He wasn't killed by enemy action, but he died because of illness. But he was a brilliant man, and he looked at the properties of something like a black hole and, set up the equations that allowed people to kind of understand what they were. But they were never really given any attention. They were regarded just as curiosities, probably a property of relativity, something that didn't really exist. So what's the point in talking about it? And it was only after the war, the Second World War, that people really started thinking about it seriously. And it was the person who actually coined the term. He was one of the great physicists of the 20th century, John Wheeler. He, in 1967, coined the term black hole to describe this infinitesimal point that basically has all these wonderful properties. Something I didn't know, which I've just read, before 1967. In Russia, they called black holes frozen stars, which is really quite a nice term.
Yeah.
But black hole has become the accepted term for these things. But Andre is absolutely correct. There is no hole. He called it a black hole because nothing can escape from it. That's why he gave it that terminology. But in the physical, the physical aspect of it, there is no hole there. He may have been thinking 10 years before John Wheeler coined the term black hole, he'd coined the term wormhole. And a wormhole is actually a theoretical entity that comes out of relativity. It's like a tunnel that's a shortcut through space-time. The theory of gravity, theory of relativity permits such a thing to exist, but we've never discovered anything that could be a wormhole. So he was pretty good with his holes. He liked the term hole. So a black hole, really almost a glib term to describe something which has such intense gravity that even light cannot escape from it. And that's where the black comes from. But the hole is really, as Andre suggests in his text or in his email, the word hole is really a misnomer. What determines the size of the hole? Well, we think in terms now of a black hole. So the black hole itself is the point with infinite density, but there is a region around that where you can sort of define a distance from that where light cannot escape. And that we give a name to as well. We call it the event horizon. You and I have talked about that because we've talked about the Event Horizon Telescope, the EHT, which is trying to get images of this thing. So that would be, if you could come up close to one of these, and I don't advise it, it's a bit dangerous, but if you could, what you would
steal
see...
your wallet, that's what we're saying.
Not to mention your feet and your arms and your legs and any other bits that you have as well. Yeah, so the event horizon is the dark part of the black hole. It's what you would see. You'd see just blackness. Although, in fact, we expect with the Event Horizon Telescope to be able to see the swirling mass of material that's being sucked into the black hole itself. So, and the size of that event horizon is what determines, or is determined by, the mass of the black hole. So even though it's a single infinitesimal point, it can have different amounts of mass concentrated in it. And the amount of mass in it determines the size of the black hole itself.
And
by the the diameter of the event horizon. I beg your pardon. That's
now, I don't know if you covered this part of his question. Where does all the matter eaten by a black hole go?
Down the hole.
Yeah.
And
So
I think
it's not a hole, but it goes down the hole.
Yeah, it's not a hole, but it goes down the hole. So it winds up in this infinitesimal point, the point of infinite density. That's where it all goes.
It's very confusing, Fred.
It is totally counterintuitive. We just can't get our brains around it. But I think, in many ways, a black hole helps you with that because it implies it's black and there's a hole that things can go down. And that's what happens.
It's a big nothing.
It's a big nothing, yeah.
It's a big nothing of something. I don't know how to define it.
I'm not actually sure, Andrew, whether that is terribly helpful, but thank you for that anyway.
I try. I am trying.
Full marks for trying.
Yeah.
My
wife says I'm trying too.
I think the term is going to stick, actually. I think black hole's been around.
I think it's around forever, yeah. I once did a radio quiz question on a black hole to see if people could figure out where the term came from. It took a long time to solve. But not as long as it's taking to solve what a black hole actually is.
Yes, that's right.
But thank you, Andre, for the question. Hopefully we covered every element of it. We enjoyed the gravity of your interpretation too. And we welcome your questions anytime. We're getting so many, it's reaching a point where we're going to have to probably dedicate 10 or 15 episodes to questions only, which obviously isn't feasible, but we'll have to cherry pick them, I'm afraid. But,
we should do Andrew, what we did with episode 100. Every time we get a significant number, we should devote it to questions. How's that?
Yes, that sounds great to me. We'll do that in episode 200. What are we up to now? 116. Anyway, thanks, Andre, and thank you for your continual support, and that applies to everybody. We appreciate it greatly, and don't forget to tell your friends. Follow us on Facebook and Twitter and all those places. Fred, as always, thank you. It's been great fun.
Great fun, Andrew, as always, and we'll see you soon.
Indeed, we will. Fred Watson, astronomer, joins me every week here on the podcast we like to call Space Nuts, and we look forward to talking to you again next time.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.
But you turn it on and off again, and it seems to be all right.
Yeah. Okay.
So
well,
hopefully that'll be good.
And my levels are all right?
You sound great, yes.
I know that, but my levels are all right. Oh, dear.
Bum tish. Yeah.